Hello everyone, my name is Georgianna Lin, and with my fellow researchers, that's Starner and Jason too, we present conversational greeting detection using captioning on head-worn displays versus smartphones. People who are deaf and hard of hearing often have difficulty realizing when someone is attempting to get their attention, such as calling out their name. This is especially the case while navigating in or mobile. Speech recognition, coupled with a head-worn display, may actually aid in this awareness. So we sought to test whether a head-worn display or a phone provides better name awareness while on the go. So our participants are given a navigational task where they split focus between monitoring captions for their name and navigating to a destination. Since one goal is improving our experimental design, we chose to have hearing participants emulate being hard of hearing, reserving for later our deaf and hard of hearing participants who are often oversubscribed with experiments. So for our procedures, we conducted a preliminary study with 3 subjects before we could test more due to COVID-19. Our participants navigated between rooms in a scavenger hunt-like fashion, while wearing the Google Glass EE2 or holding a Razer phone. Each room has a note that directs the user to the next room. During navigation, the participant sees a randomly selected distinct name every 8 to 12 seconds, and with their name showing roughly every 4 names. When the participant sees their names, they will press a button on a handheld controller. At the end of each condition, participants complete a NASA TLX survey. Then at the end of the experiment, they complete one more questionnaire that assesses their preferences between the conditions.
Preliminary results show average response time was indeed better, with a p-value of 0.033 for the head-on display, with an average of 2.7 seconds, compared to the phone, which had an average of 4.3 seconds. The head-on display ranked more comfortable than in the phone, with a p-value of less than 0.001. Negative scores on a NASA TLX graph indicate lower head-on display workloads. The head-on display's 1.63 second improvement in average response time and lower standard deviation, 0.706 seconds versus 2.222 seconds, shows potential for utilizing the head-on display as an assistive device for responding to events consistently, whether or not it is being used for hearing assistance. For the future, we plan a larger scale study with 12 deaf and hard of hearing participants. Future refinements to the study might also include using vibration for name detection and ambient environmental noise, and conversation to use as distraction instead of random names. Thank you.